Okay, for homework 1020, I'm going to have you copy the work for these 11 key problems and then show me that you listen by writing down 5. There's going to be 5 words on this video, so look for the 5 words. Do this work on a separate piece of paper, and then you could use that to check your mind map if you want. But here we go. Do this work on separate paper. Do not use the same piece of paper as your mind map. Separate piece of paper, please. All right, here we go. Number 1. That one is the plug in the calculator one. They give you the first term and they tell you what you're multiplying by each time. So please don't miss this one. They tell you that you're starting at 7. They're telling you to multiply every number by 3 to find the next 4 terms. Don't just give me 3, give me all 4. Use your calculator, plug it in. Don't erase it. Just take that 7. 7 times 3 gives me 21. Don't erase it. Leave it in there. Take 21, go times 3. Don't clear it. Leave it in there. It gives you 63. Don't clear it. Times 3 gives me 189. Don't clear your calculator. You might make a mistake. Times 3 gives me 567. First word is blue. Blue. All right, number 2. For this one, the graphs that I gave you, sketch these on your paper best you can. One has straight dots, one has curve with no dots, one has curved dots. Anything with dots, let's go straight or curve. If it's straight, it's linear. If it's curved, it's exponential. So that first one is straight line dots, linear. Next one, curved, exponential. Even if it's curved dots, exponential. So linear, straight, exponential, curved. The next category, dots or not. If you have dots, discrete. No dots like this one, continuous. Dots, discrete. So that first one is linear, discrete, exponential, continuous, exponential, discrete for number 2. All right, number 3, here we go. This one, I want you to be good at getting this problem tomorrow by matching, finding that one out of the bunch that has the number in the wrong spot. I'll try to show you. That one right there. This one right here. This one right here. And this one. So I'm telling you, on test day, you could count number of boxes, or you could do it this way. Look at the recursive form. Know that that 5 will match 2 of the others' 5s. Look at that 5. Look at that 5 right there. The only one of all of these that doesn't have the 5 in the right place is this one right here that has a 3 in front of that X. That's the oddball one out. Look for these matching numbers tomorrow. Find the one that doesn't have that. It has 5 here, but remember that 5 is not in front of X. That 5 is not part of the recursive formula. That makes this one the one out of the bunch that does not match that data. That's the one you choose. That one is no good. If I do 3B, that one is tied to this problem. Know that this one with the 5 in it, that one is money. That's the one you're going to use to plug in for the next problem on the test. That one, the one with the proper 5 in its right spot and the right y-intercept, I'm going to use this one to plug in 25. This is the only problem that you're plugging in a number for X and doing any math. This is the only one. So plugging in 25 for X, times in that by 3, that gives me 75 plus 3 gives me, when I plug in 25, gives me 78. Second word is whale. whale. All right, problem number 4. This one, again, has you matching. It gives you this equation right here with 1400x right here. Remember, do this on a separate paper, but then use it to check your answers on your mind map. So this one right here, this is my rent. This is my deposit. The number in front of x, that is rent. So look for that number in front of x. That's the number that's changing. So if I give you these choices, like choice A says the deposit is 1400, because that's saying the number in front of x is the deposit. Nope, that's not correct. If the second choice though says the deposit is 300, that is the one not attached to the x. That is the deposit. If I look at that third choice for C and it says the rent is 300, that one is showing me the deposit number. That would be no good. If it says the rent was 1400, then I would say yes. But this says the rent is 300. If I look at that next one though, it does say the rent is 1400, that number in front of x. So that one is good. Know that the third choice tomorrow is going to have you take the first month's rent and take the deposit and add it up and see if it equals the number they're giving to you. So if I add it up for this one, the first month's rent 1400 plus my deposit tells me after 1 month I'm spending $1,700 to live at this place. All right, number 5. 5 has you look at a geometric sequence, but I specifically want you to use the zero term number. So again, in a sequence, if you want to find out what you're timesing each number by, the trick is to take the one before it and divide by the one in front of it. That will always give you the number that you're timing. So if I use this one, if I divide 5 by 15, it gives me 3. If I divide 45 by 15, it gives me 3. So that's what you're doing for this problem. You are finding out what number you're timesing by taking the first number and dividing it by the one before it. So taking 315 and dividing by 300, or taking 330.75 divided by 315, the one before it. No matter what, either of those, when I divide it out, is going to give me 1.05. That is my common ratio number. This is definitely geometric, timesing by 1.05. This wants the zero term, so I'm going to use this 300. This explicit function is f of x equals that zero term 300 times that key r number that I got by dividing. And since this is the zero term, that's just plain old x right there. If they had you use different letters, I could use a 300 1.05 and put an n up here. So just be aware they're going to be using those letters right there. For number 5, explicit form using the first term, or not the first term, the zero term. All right, number 6. This one gives you some numbers. Recursive, negative 54, negative 42, negative 30. The third word is gray. Gray is the third word. Negative 18. For this one, it's tricky. But to get from negative 54 to negative 42, I'm adding by 12, making some of those negatives go away. This is my first term, second term, third term, fourth term. If I want to write recursive, easy as this, because I have the first term and I know I'm adding 12. First term right there, if I was to list it, is f of 1 equals negative 54. Recursive. If I was to do explicit, get in the habit of just jumping straight to that first term. Don't try to get fancy. Explicit with that same 12 in front of x minus 1 plus or minus that first term number, negative 54. That's my suggestion right there. Otherwise, you're having to backtrack and take away 12. And some people struggle with that. Negative 54 minus 12 gives me negative 62, I believe. No, yeah, negative 66. So negative 66 plus 12 gives me negative 54. You could go back, but I would not suggest that. Some people messing up on that, putting the 12x, but then not minus 54. Nope. 12x minus 66 if you're using the zero term. But for me, get in the habit of getting good and using the first term gives you the same answer every time. All right, number 7. Another sequence here. This looks geometric. Looks like this one has me divide by 2, but remember there's no dividing by 2, even though that's what I'm doing. I'm timesing by the reciprocal of 2. I'm timesing by a half. So we never show division. Dividing by 2 is the same as timesing by a half. Those are my first, second, third, and fourth term right there. If I was to write recursive, here we go, recursive. Times 1/2. Making sure recursive, I'm always giving that first term. For explicit, I'm going to be good at using that first term instead. So explicit, I could use that first term, 144, times that 1/2, and it's that 1/2 raised to the x minus 1 power if I'm using the first term. If you try to go back to the zero term, might be trickier because you're timesing by 2. You'd have to take 144 times 2 to get that true y-intercept term, 288. Could have used that one too, but again, some of you struggling a little bit going back, you might want to always just use the first term one, so you're not having to worry about if that's 288. You're not having to worry about if there's an x there or not. All right, and then again, for those of you listening, be careful. They're going to be so close on their answers. They're going to have one answer with 288, but 1/2 not to the x, but the x minus 1, which makes that no good. Then they'll have another answer close to this one with 144 times 1/2, but they'll have it only to the x power, which makes that no good because zero term is x, or first term is x minus 1. So all the things you need to worry about. All right, number 8. For problem number 8, has me do another sequence here. I'm telling you, best way to do this, find your rate of change right here. Find this rate of change right here. Divide those out to get your common ratio number, your D number. That should give me 2 for that. I could have got that same answer by taking this step right here, going up by 6. This is going up by 3. If I divide 6 by 3, that will give me that same 2 answer for my rate of change. My pen lets me write. All right, and for this one, I would suggest doing this, jumping straight to the recursive formula answer. Recursive, because they're not asking for any specific form. Plus 2. Make sure if you're doing recursive, you always give me that first term. First term is 5. If you want to get high tech with this problem, you got to know that if I'm jumping up by 2s, I'm going up each time by 4 and by 2. But if I divide that out and find out what I'm doing for single digits, that's where this gets tricky. If you were to fill in this table and find this second term and this 0, 1 and this fourth and fifth, you're not going up by 4 every time or 6. Now you're just going up by single increments 2. So what that means is if I start with 9, 9 plus 2 gives me the fourth term 11. 11 plus 2 gives me 13. 13 plus 2, 15. Going up, 9 minus 2 gives me 7. 7 minus 2 gives me 5. 5 minus 2 gives me that all-important y-intercept number, which is 3. Some people are giving me explicit forms on this, but I would not. I would give me the form I just gave you. Otherwise, you're having to write it like this, that 2 times x, and having to find that y-intercept of 3, or using that same 2 times x minus 1 and adding that first term, which is 5. Not many people do that. And again, you could use both, because remember, if you distribute this and you add that 5 and that negative 2, it gives you the same exact equation. They are equivalent. All right, let's keep going. Number 9. 9 has you find which one is geometric. And if I didn't say it, the fourth word is wolf. Fourth word is wolf. All right, so for this one, adding 3 all the way makes that straight line linear, makes this straight line arithmetic, but this one wants geometric, so that one's out of the running. This one going up by 2, and then going up by 8, and then going up by 10. That's not going to be geometric. There's no number times 2 to get 4 and that same number to get 12. So this is one of those weird neither ones. But it's not exponential geometric like they're looking for. For this one, timesing by 2, timesing by 2, timesing, that makes this one the exponential one. That's the one. I'm timesing by the same number each time. If I graphed it, it would be a curved line. This is geometric, all those things. This next one's no good because going up by 5, going up by 20, going up by whatever that is, that would not be timesing. That would be one of those neither ones. All right, number 10. Almost done. One more after this. 8, 16, 32, 64. This is the first one right here. Second, third, fourth. This one looks like I'm timesing by 2. If I had to write both forms of explicit, for this one I am going to have to go backwards to the 0 term, timesing by a half or dividing by 2, taking this 8 divided by 2 to get 4. Explicit with both terms, I could either use my 0 term times that r number to the first power if it's the 0, 1, or if I'm using the first term one, it would be that 8 right there times 2, but raised to the x minus 1 power. And again, notice on those I'm not giving the first term because they're not recursive. All right, 11, and then the last word. So 11 has you look at this. If I look at day 1 going from 4 miles, day 2 going 7 miles, day 3 going 12 miles, because I'm going up by 3 here, but then jumping up by 5, that makes number 1, or it makes that first one for Joe walking, makes that a neither. It's neither straight nor curved, neither linear or exponential. The second one, my lawn. When you see that my lawn's growing 4%, that's automatic exponential. If that first one I just did was going up by 3 all the way, that would make that linear. But again, because it's changing, that makes that neither. Any number with a percent, always exponential. And the last one, I got to do a little bit of math. I got to find the unit rate. Take that $60 divided by 3 to get $20 for every 1 hour. Divide 80 by 4, and that gives me that same $20 per hour. Since these rates are the same, these D numbers are the same, that means this is going to be a straight line with the same slope. Makes this linear. The fifth word is dog. Dog. So make sure again you did these 11 on a separate piece of paper. You could use these answers to check your mind map to make sure your mind map was done. Tomorrow you're going to turn in your mind map and this work on a separate piece of paper. Good luck.